Essential Objective 2A says, I know and can use proper geometric notation. Before we look at the example, let's review the notation for each of the congruency transformations. First, a translation. So a translation is noted in function notation with a capital T, along with a subscript which tells us the distance and direction, which is noted by a vector. Remember, the H tells us the horizontal shift and the K the vertical shift. Next, a reflection. A reflection in function notation will be noted with the capital R, and then the subscript tells us the line of reflection. Lastly, a rotation. A rotation will be noted with a lowercase r, and then the subscript will give us the details of the angle of rotation as well as the center, where our rotation is going about. Okay, so let's look at the example. The example is asking us to describe the following composite transformation in words. Remember, a composite transformation is a sequence of transformations. So when a composite transformation is written in function notation, it's very important to remember that we read it from the left to the right. From the right to the left. So I would first start on the right and move to the left. So if I use the key above, which reminds me of each of the transformations with its symbol and function notation, the first one is telling me to reflect, and the subscript is telling me my line of reflection, which in this case, we're reflecting in the x-axis. Second, if again I use the information above, the capital T is telling me to translate, and the subscript is the vector, which is the distance and the direction. So the H value is telling my horizontal shift, so in this case it's negative, so I'm going to go left 4 units and down 6 units. Again, remember, when a composite transformation is written in function notation, we want to work from the right to the left.